Welcome back to the Bioprocess TEA calculator. If you have not watched the overview video or the first several tutorials, I suggest you do that now. In this tutorial, we will walk through the basic components of the calculator itself. Once you have logged in, you can navigate to the calculator page. As a reminder, the user inputs are all on the left navigation pane, and the results are updated in the main window. The input is broken down into 6 different areas: the target chemical input, financial inputs, plant level inputs, raw material inputs, fermentation inputs, and downstream purification process assumptions. As mentioned, results are updated in the main window. There are several key outputs. Firstly, at the top of the page is the summary of the financial results. These include the target selling price, the operating OPEX and capital CAPEX costs per kilogram of product, the total capital investment needed to construct the facility, the project's estimated net present value, return on investment, and the internal rate of return, and the minimum selling price required to achieve a given target margin. The next results are the projected cumulative cash flows over time. This cumulative plot enables you to see the investment period, maximal debt, the break-even point in the project, and the cumulative cash out at the end of the project period. For more detailed cash flows, you will need to save your analysis and export it, which you will get to later. The next results summarize the chemistry, including the input chemical name, its molecular weight, and the theoretical yield from glucose. The yield is determined by the balanced conversion equation. It is important to note that this conversion represents the theoretical maximal chemical conversion and is not specific to any particular biochemical or metabolic pathway. In many cases, the theoretical yield for a given metabolic pathway to produce a chemical is less than the maximal chemical conversion yield given here. The next results are the process results. These summarize the highlights of the bioprocess, including the optimal annual production capacity, the rate, titer, and yield from the fermentations, final estimated biomass levels, and the specific production rate in the fermentation. The specific production rate is the amount of product made per gram of dry cell weight per time. Additional outputs include the fermentation time, as well as the estimated maximal required oxygen transfer rate, the needed mass transfer coefficient, or KLA, and the maximal cooling rate in the fermentation. These can be checked to ensure the modeled fermentation is feasible in realistic aerobic bioreactors. Additionally, the downstream purification yield and overall process yield are given. These results are followed by a predicted fermentation time course, where biomass levels, the number of cells, as well as product concentration are plotted as a function of time. Biomass is given in grams of dry cell weight per liter and product in grams per liter. Lastly, the results include a breakdown of the estimated operating costs, OPEX, and capital cost, CAPEX. The operating costs are broken into the feedstock costs, including glucose and ammonia costs. In this process model, ammonia is used as the nitrogen source. The media costs and the associated costs of aeration and cooling, the cost of sterilization and biomass disposal, labor costs, the crude cost estimate of the downstream purification, and other fixed costs. These other fixed costs include depreciation and other essential costs to keep the plant operational. The CAPEX is broken down by the key areas of the facility, including the main production fermenters and associated equipment, and the seed fermentation equipment. The cost of the centrifuges used in primary cell removal or removing the cells from the broth, the process utilities and control systems for the fermentation part of the facility, and the crude estimate of the capital costs for the downstream purification process. Lastly, you have an option to save a given analysis. Once saved, the calculator will take you to your TA history, which includes all of your saved analyses. The summary on this page includes the chemical name, minimum selling price, and creation date. If you click on this, you will see a more detailed summary, including much of the information on the main calculator page, and you can choose to download the complete results. Downloading the complete results will get you a CSV file with a complete summary of the analysis. The CSV file includes the summary output information on the main calculator page, as well as all of the inputs for this analysis. It also includes the fermentation time course, and a more complete pro forma from the discounted cash flow analysis. Lastly, it includes a much more detailed breakdown of the capital costs by area. This complete information is provided to enable additional user-driven analyses or summaries as needed. These are the basics of the calculator itself. Please check out our next tutorials, and thanks for watching.